Hi everyone, this is Becky, and in this video we're going to take a look at how to find the molar mass of a substance. So the goals of this video are to be able to determine the mass of 1 mole of substance using a periodic table, and then to be able to convert or to start to convert between mass and moles and vice versa. So thinking about how we go from a mass, something we can measure, to a number of particles. We've talked in class about this idea of a mole, right? And we said that because we need to be able to count atoms, we need a unit that represents the number of atoms in a sample, and that unit we use is a mole. So we have 1 mole is defined, of anything, is defined as 6.022 times 10 to the 23rd of whatever that substance is. So if I have a mole of elephants, I have 6.022 times 10 to the 23rd elephants. Just like a dozen is 12, a mole is 6.022 times 10 to the 23rd. So this number is ridiculously huge and really doesn't make sense for us to use in terms of anything other than moles, right? But this tells me how many particles I have. So for example, remember that if I have like 0.75 moles of water, right, I can calculate the number of molecules of water because I know that I have 6.022 times 10 to the 23rd molecules of water for every 1 mole of water. So I can convert between molecules and moles, and if I have a sample that is, 3.6 times 10 to the 24th molecules of methane, right, and I know I can figure out how many moles of methane that I have because I know that there's 6.022 times 10 to the 23rd molecules of methane for every 1 mole. And so I can put these in my calculator and I can get an answer. And so basically what the mole is it's just a unit that's convenient to talk about a large number of teeny tiny things, which is great, which really helps. But the problem is that I don't have a way to measure moles. All right, my scales don't read moles, they read grams. And so I don't have a way to directly measure the number of particles in a sample. So what we need is a way to convert between something that we can measure, so for example grams, to something that tells us how many molecules we have, or moles. So I need a way to convert between grams to moles. And the way that we're going to do that is to look at the numbers on the periodic table. So when we look at the periodic table, let's say that I have, for example, carbon. An average carbon atom has a mass of 12.01 AMU per 1 atom of carbon. Well, cool thing is that the reason we use the 6.022 times 10 to the 23rd number instead of a more round, pretty looking number is that this is the number of particles that weigh in grams what 1 particle weighs in AMU. So 12.01 AMUs per atom is the same thing as 12.01 grams per mole of carbon. So if I know the formula, I can calculate the molar mass using the atomic weights on the periodic table, but now so molar masses are atomic weights. They're those atomic masses, but they're in units of grams per mole. So for example, if I'm finding the molar mass of NH3. So in this case, I have 1 nitrogen and 3 hydrogens make up a molecule of NH3. So in my sample, if I look on the periodic table, nitrogen has an average mass of 14.01 grams of nitrogen for every 1 mole of nitrogen. And I have 1 of those, right? And then I have 3 moles of hydrogen, which has an average mass of 1.01 grams hydrogen per 1 mole of hydrogen. And when I do that, when I put that in my calculator, I get that NH3 has an average mass of 17.04 grams of NH3 is 1 mole of NH3, right? So when we made those mole bags that we looked at in class, do you think that we sat there and counted out every atom or molecule? No, we calculated the molar mass and then we weighed this out. So if I wanted to have a mole of NH3, it'd weigh out 17.04 grams. Okay, we are going to ask for the first couple that you do that you show all of your work using dimensional analysis in a way similar to this. As you get to do more and more, then you can eliminate the amount of work that you're doing, but it's a good habit to get into to think about that. Given that, Here's some practice problems looking at calculating the molar mass. pause the video, try these, and hit play when you're ready to see the answers. Okay, so let's take a look at water. Water is H2O. I know that I have 2 hydrogens, and each hydrogen has an average mass of 1.01 grams of hydrogen per 1 mole of hydrogen. And I'm adding that, and I know that oxygen has an average mass of 16 grams of oxygen for every 1 mole of oxygen. So when I put that in my calculator, I get that the molecular weight, which MW, molecular weight or molar mass of H2O, is equal to 18.02 grams per mole of water. Okay. If I'm looking at CH4O, I'm going to do the same process where I have 1 carbon, which has an average mass of 12.01 grams per 1 mole. And then I have 4 hydrogens, which has an average mass of 1.01 grams of hydrogen per 1 mole. And then I have 1 oxygen, 16.00 per mole. So that adds up to be 32.05 grams per mole of CH4O, sorry. CH4O, right? And so we can do the same exercise, and when you do, you'll get that the molecular weight of manganese, of MnCl3, manganese 3 chloride, is 161.29 grams per mole of MnCl3, and calcium phosphate has a molar mass of 310.18 grams per mole of Ca3P. 042. So, this being said, notice a couple of things. We're always carrying our molar masses out to 2 decimal places. So from the periodic table, don't round on the periodic table. Always carry out to 2 decimal places. And then, again, make sure you're including the substance, because remember, molar masses are going to be substance specific. Different substances will have different molar masses. So, given all of this, the question that I'm going to leave you with, that I'd like you to bring to class with you tomorrow, is to say, okay, I have 10.3 grams of nitrogen. I want to know how many moles of nitrogen are in my sample. Okay, give that a try. Bring it to class with you tomorrow. Remember, you must try this question in order to get full credit from your homework, and we'll see you later.